Well, in Houston, I'm John Herder. It's Tuesday, the second day of May. It's great as always to have you along, everybody. In a nutshell, From the Experts is a virtual networking opportunity flow accelerator, helping leaders across industries connect very quickly in a brief, moderated, interactive show format, like a TED Talk with interaction. If all goes well, as your curiosity is sparked, new ideas accelerate into action, and you may have helped yourself or somebody else solve the problem, make a connection, reach the opportunity faster. Networking has never been more important for your business. I want to thank the FTE sponsors and partners, Hewlett Packard Enterprises, Endeavor Institute, Unique Ventures, Ecosystems 2030, and the Canon, and individual members like you. Your support is absolutely vital for our important work together. Folks, help me welcome our guest expert, Abhijeet Inamdar. Abhijeet is the founder of SiriNoR, a startup committed to making aviation emission-free. Abhijeet founded SiriNoR after 20 years in the industry, the energy industry, where he also focused on venture tech investments in a wide array, including unconventional oil and gas, hydrogen, industrial blockchain, and carbon capture. Experiences all that shaped his understanding on how to develop, commercialize new tech products, and build strong teams. Serving as a board member or advisor on over a dozen companies, Abhijeet has been recognized 40 Under 40 by Heart, Most Admired Global India, Passion Vista Magazine, and Entrepreneur of the Year by Indian Achievers Forum. Abhijeet, man, I'm really grateful that we've had this time to reconnect with you as you're kind of moving from hydrocarbons to hydrogen. And today, really better to understand why you selected hydrogen with an all-electric engine package and some of the key challenges you're facing, to see maybe this group here has some things they can offer to help you guys along the way.
All right. Thank you, John, and thank you, everybody, for making time. Yeah, definitely excited to share part of my journey, which is from hydrocarbons to hydrogen, as John mentioned. So today, I hope we all look at some of the challenges in aviation and then how electrification of aviation can solve those challenges. But at the same time, there are obviously challenges implementing the viable options of electrifying. So we'll discuss some of that. But before that, I would like to share a brief video what SiriNoR is doing. Then we'll come back to a couple of slides. So John, if you could play the video. Gus, can you unmute, please?
Our purpose is to deliver electric propulsion technology to eliminate greenhouse gas emissions. Aviation is responsible for about 3% of global CO2 emissions, or almost 1 billion tons of CO2 each year. If no further action is taken, aviation's share of global CO2 emissions may grow to 12 to 18% by 2050. Compounding the matter are non-CO2 emissions such as nitrous oxide, particulates, and contrails, which have a 2 to 4 times higher impact on climate change compared to CO2 alone. Electrification is the best way to tackle this problem. We believe that recent advancements in battery energy density, fuel cell technology, green hydrogen production, and storage will usher in a new era of true zero-emission aviation. SiriNoR will be at the forefront of this revolution. Our unique engines are driven by an electric propulsion system. The energy can be drawn from a battery pack or hydrogen fuel cells, or a combination of the two. Compared to sustainable solutions based on turboprop engines, our engine allows for larger aircraft, greater distance, and higher speeds, even supersonic speeds. We believe we have the only sustainable concept for long-haul aviation. Because our engines are non-combustion engines, they are less complicated and less expensive than standard jet engines. For more information, please visit our website.
So let me share a couple of slides and then we'll get into discussion of how everybody can help, I guess, decarbonizing aviation.
I'm also turned on a poll, so if you guys could answer that as well.
Okay, do you see these slides in full screen?
Yeah, we got it. Good to go.
Okay. All right, so let's discuss a couple of interesting things happening here. Aviation, I think, and I think most of us do understand, do bring people closer together. And more people will be traveling in future, especially because the population is going to grow. We all love to travel, see places and all. Even though pandemic kind of restricted some of that, we think it's going to come back. Number of flights globally, the trend is going to be double by 2050. That's the estimation. And also private jet aviation is booming, especially during pandemic. It picked up and it's continuing to boom. It's really picking up pace. On the other hand, the supersonic aviation, especially the commercial supersonic travel is also coming back. But both of these have one big problem. They are extremely carbon intensive, anywhere from 5 to 10 times than the existing commercial travel. The other kind of macro trends which are happening, especially in Europe, is the term called shaming, travel shaming and all that, which basically means people like to see less traveling by air because of the jet fuel emissions than taking the electric trains and all. But we think instead of banning the private jets or banning travel, we should come up with a solution that's electrified or zero emissions. And this is where SiriNoR is working. If I can change the slide here. With the unique hydrogen electric propulsion system that is reducing all type of emissions, the CO2 as well as non-CO2 emissions such as SOx, NOx, and etc. The way this will work is we'll have a hydrogen storage tank on board. We'll have a multi-stack fuel cell system, oxygen concentrator, depending on the height, and then our engine, that's the early stage TRL level here. How it will work is the hydrogen go from the storage tank towards the fuel cell stack, oxygen either from air or concentrator into the fuel cells. Electricity will be generated by chemical reaction, and that electricity will be used to run the motors, which will in turn will run the system as a whole, and that will give the enough thrust that's required for the jet engine. In the whole setup, the only emissions here would be the water vapors. So this setup has already been tried and tested in automobile industry, as you know, by Toyota Mirai and others. It's also been tested in propeller aircrafts by companies such as Zero Avia and Universal Hydrogen. They have done a fantastic job putting all this together and testing in 19-seater as well as 40-seaters recently. And they are so confident that this will all go through the certification and regulators that they would like to bring this to commercialization by 2025-26. The other major players are also working on this, such as the Rolls-Royce, Airbus, and few other players. But keep in mind, the propeller aircraft is only the 15% of the total addressable market in terms of traveling or the engines itself. And this takes care of only the short distance flights. The bigger market, that's the jet, which is 70% of the TAM, especially the long haul flights and all, that's more important to decarbonize. And some of the actions are being taken by big players, such as the Rolls-Royce, Airbus and all. But most of those are focused, especially the articles we found online, they are focused on the hydrogen combustion and also using the SAF and a few other things. But again, all these solutions, since there is a combustion part, they will not eliminate the non-CO2 emissions, which are major greenhouse gas emissions, as we saw in the video. So the viable options to reduce all type of emissions is electrifying, and the two ways to do is the batteries as well as the fuel cells. Both have the challenges that we all have to address, and I'm sure some of you guys are working on those, which I would like to hear. The storage and transportation, safety factors, the full value chain or building the full infrastructure, the range, especially in the usage of batteries, you cannot fly more than 1,500 kilometers and all. So anyway, these are the challenges. Some of these things I would like to discuss and hear from you. And as John has started the poll, I would like to see what the poll results are, and then open up for questions and also the discussion.
Guys, go ahead and finish up the poll questions, if you wouldn't mind. If you haven't done it, we've got about 75%. Thank you very much, Abhijeet. So those of you that are new to the FT show, This is that's the expert talk. Now we're going to open the floor up. We're going to continue to use the chat, but also use the raise the hand tool if you like to verbally share. So we have a couple questions, and Gus, if you go ahead and drop the first two in there for you to think about, respond to. You may also have something that you're thinking about independently that you heard Abhijeet say, or you just ask a question that you want. So please raise your hand or go ahead and send it in the chat. So with that, I'm trying to see if there's anything else. I think that's it. Do we have anybody on the floor who would like to go ahead and let me go ahead and conclude the poll. I'm going to share the results, Abhijeet, as we go to the floor. Here what the results say. These are the folks that have responded.
Yeah, so how concerned are you about environmental impacts? I'm glad to see some of them or most of them are concerned. So
Right.
That's a great start. How important is it to for you to fly airline that prioritize sustainability? Again, majority of you are saying yes, so definitely a relevant topic then to discuss. If you scroll down a little bit, what's next? What's the best way to eliminate emissions from long-haul commercial aircraft? So using SAF is one of the answers. We'll discuss that. Using batteries, a few of them, fuel cell combustion. So a good mix of that. And then what I would say, at least in my opinion, for long-haul emissions, batteries, as I discussed, range is the problem. So hydrogen combustion becomes hydrogen combustion as well as SAF are solution, but they will not take care of the non-CO2 emissions as we discussed. So I think the fuel cell way of, or the electric way using fuel cell is the long-term solution.
Got it.
What's the best way to store hydrogen? Anyway, so those things, but would like to hear from you guys and John.
Yeah, thank you. So Sandeep says safety regulations are not established in aerospace. So how are we going to move ahead with this?
Yeah, no, thanks for that. So as I mentioned, some of the two companies that have done the testing, especially in the propeller aircrafts, the using hydrogen fuel cell system, they are already working with the regulators, and most of the countries are under the pressure after the Paris Agreement and the net zero goals that everybody's putting together. So policymakers most likely will be conducive to work with the technology providers as well as airliners, aircraft manufacturers, all the players in the system to make sure we bring the right solution to the market, and everybody has to work toward net zero or zero emissions altogether. So that I don't think that's a question of if, it's going to happen, it's when. So that's my opinion. I would like to definitely hear from others who might have something else to say.
Right. So you can raise your hand or you can just step out and take the microphone now. So as we're waiting for that, we have folks that are coming from the automotive industry. We have folks that are coming from oil and gas, from legal, from venture capital. Steve Cohen, I know we talked very briefly in the beginning. What's your reflection from what you've heard from Abhijeet? Anything to share?
Well, I think the way I would pose, I guess I wouldn't pose it like an either or question. You know, should we be using batteries or hydrogen fuel cells or sustainable aviation fuel? I think there's going to be a natural evolution toward electrification in aviation. You know, it's a ways off, and there's many challenges to solve. Something like, you know, in comparison, sustainable aviation fuels can be nearly, if not a drop-in for airlines, and their carbon intensity is significantly lower than you know, oil and gas based than petroleum based fuels. So if you think about, you know, the area under the curve of carbon that we're putting into the atmosphere, it's, even though sustainable aviation fuel is more carbon intensive than, let's say, fuel cells or electrification, it's still, in my opinion, a very worthwhile thing to push for as soon as possible so that we can start reducing the amount of carbon that we're putting into the atmosphere. And then as electrification becomes technologically and economically and regulatorily viable, we move to it. But in my opinion, it's still, there's many challenges to solve, and we should not overspend now on solving those problems to the detriment of things that are virtually here, like sustainable aviation fuel.
So Abhijeet, any follow-up?
No, I think I agree with you, Stu. I mean, the interim solutions have to be there, and as you said, all solutions have a role to play. For example, batteries, short distance travel makes sense with batteries rather than going for all fuel cell. Similar to what car industry, automotive industry is doing, there is room for everything. And end of the day, the goal is to get towards net zero. So any low carbon solution helps, and obviously. The fuel cell wise, it is harder in terms of implementation. So all technology development has to take shape and make sure all the safety concerns, everything is addressed before it becomes a real solution for longer term.
So just a real quick one. Several folks are like, can you give us a feeling for how close are we to SAF in jetliners? Do anybody know? How are we months away, years away? Steve, Abhijeet?
I am not really sure, but I guess the big difference is that chemically, these fuels are identical to petroleum-based fuels. Like nothing has to be, in principle, nothing has to be changed in the infrastructure in order to utilize these fuels. So from a technological standpoint, we're there. From a regulatory and business standpoint, I don't really know, but not far.
Yeah, so in terms of SAF, a couple of things I can add, if I may, is the biofuels, obviously, that can be easily implemented 10%, 20% of, but the challenge is it is competing with the feedstock. So it may or may not compete in long term, but there is synthetic SAF that's coming up also, which right now is expensive, but in future technology development, it will be competitive.
Right.
But overall, SAF will be, in terms of meeting demand, it's not going to be the only solution, as we all know. So.
Yeah, so some of our members are reporting that, yeah, it's already flying. It's just not in a large way, right? So we're getting there. Now, some questions on the all-electric technology. Where are you in the TRL process as one of them? And then one of our other members is saying, hey, wouldn't it be easier to start with something small instead of a long-haul jetliner?
Yeah, no, absolutely. It is easier to start small, and that's what the industry is doing step by step. As I showed you, the zero ABI universal hydrogen and few others. So propeller aircrafts are the step that most people are taking. For SiriNoR, we are definitely taking a stand to go for long haul, the engine development, which is part of the puzzle. So it will also take a little bit longer, but somebody has to work on that now. So we have a solution by end of 2030. So that's the approach. But again, it is right. We have to take step-by-step approach, which includes all that SAF solution, battery solution, all electric propeller aircrafts, and all
right.
that.
So Kathy is asking, hey, what about your H2 storage? What is it made of? What are the materials you're using that are suitable there?
Yeah, so hydrogen storage wise, a lot of companies are working on that. So we personally will not be working on how to solve that problem. We'll be partnering with companies. There are solutions in gaseous forms as well as liquid form. Gaseous form has been tested recently, but long term, for long haul, we think liquid hydrogen probably will be the solution. Then yes, there are challenges on storing cryogenic conditions and all, but some of the companies are already working on that. Same goes for the fuel cell development. A lot of things are happening, and fuel cell itself, the technology is more than 100 years old. But how do you customize it for aviation, and how do you customize it for long haul aviation? That's the part we'll be solving along with some of the partners. And today, obviously, one of the things we are looking for is partners.
Exactly.
So.
Right, and investors, right?
Yes.
From the investment side or the technology side, any questions in terms of the challenges we've talked about some of them, but what else do we have out there from the group? Let's see. It looks like I've got something here. It talks about availability. Okay, Sumeda is asking, sorry, I messed up your name. I know it. Do you already have partners in the fuel cell tech? Because I know you're looking for them, but maybe you already have some there.
So the way we're approaching this is we are having discussions, and since the technology development is happening rapidly, right now we're not doing any exclusive partnerships. We are having discussions, but we're also working with the universities as well as research folks who are looking at the to customization of this long haul flights where fuel cell will be used. So definitely open to discuss if you guys are working on fuel cell technology. And since we are based in Norway, Europe, a lot of things are happening there. Engine technology wise, we're working in India, and we also have folks in the US. So we are already a bootstrapped global company, if you will, looking for partners all over the world. And since this is a global product, collaboration it's much needed. Just alone, we're not going to solve the problem by ourselves here.
So I guess that's a call out to any of you guys as you're listening to this. If you have people in your network that you think would be advantageous to SiriNoR, maybe it's your firm, maybe it's not, definitely connect with us, and we'll get you to each other. And I know that Cassie, you've asked about the presentation. Yeah, we can make that available. And I know that you guys are an interesting engineering firm. You do systems engineering, different types of things. Could you talk a little bit about that, whether it's you, Cassie, or, maybe Abhijeet, in terms of system engineering? What are you looking for there?
This is Cassie Casanova. I'm with Rhino Onward International. We're a company that actually builds hydrogen plants. So we'll be producing hydrogen and using renewable energy to do that across the country. So that's my market.
Thanks, Cassie. Appreciate that.
Yeah, in terms of systems engineering, I mean, it is a bigger problem to solve. I mean, I think the idea itself is viable on paper, technical and everything. The engineering challenges are the most important to solve. So that's one of the reasons it will take time. And in aviation, people's perception is everything takes time. But that, in my opinion, at least, is not true to 100%, because things are moving faster, especially lessons that were learned before most companies are applying them, and also the policies and funding and resources that are coming together are helping. And in terms of hydrogen economy itself, yes, the other challenges are the transportation of hydrogen itself, how the airports are going to store them, refuel them. So multiple stakeholders are working on it, and it will not be a segregated problem to solve. Everything has to come together for this to be a viable option. And end of the day, like I said, the policymakers will play a major role. The funding wise, there is a lot of funding, but sometimes, yes, I was also a venture capitalist, so we do. Most of us are risk averse, but we're definitely looking for somebody who is willing to take some risks and have the vision.
Well, so you talk about timing and the certification process. What does market entry actually look like for you guys through that whole thing?
Yeah, so for us, what we're banking on, and obviously sharing the testing that was done by others. So that helps us, because these guys they have already started the process of certification using the systems that are flying in Europe as well as in US. So we'll come on top of that for long haul systems, but it is going to take at least 3 to 5 years to build the prototype and prove it and commercialize it and all. Then the certification happens in parallel. But we are hoping the first commercial flight with this system, with our engine for subsonic jet, would be by 2030.
Got it. Any other questions from the floor? Here's one that's talking about, could you do a little compare and contrast on why hydrogen and not SAF? And is this a one part of the world versus the other?
Yeah, so why SAF? Why not SAF? I guess SAF will be there in terms of people have said, it's already been used. So we are taking, the industry is taking step to start lowering the carbon, at least using some part of SAF and all. But as I said, the biofuel, if it's competing with the food stock, it will not be a viable option. The total SAF, at least the estimates that are out there, it will meet only 10% of the demand. And if you start going for synthetic SAF, it is expensive and it will still not meet the full demand of replacing the whole jet fuel. So we need solutions. If we want to replace the all jet fuel, we have to have hydrogen as a bigger part of it. And in terms of cost effectiveness, we have done some calculations for using jet fuel versus hydrogen fuel cell systems for 19-seater all the way up to 150-seater. And what we found out that the bottom line operation cost per kilometer actually is 1/3 or 1/4 of using jet fuel, especially when you consider the taxes that are coming. And some of the taxes are already announced in Europe, like $140 per ton of CO2. And that's again only for CO2. We think non-CO2 emissions will also be taxed at some point. But eventually, if the taxes are coming, going pure electric makes more sense. And SAF, I'm not denying SAF will not be a part of the solution. It will be, but it will be a smaller part.
Got it. So we have folks that are coming from all kinds of fields out there. Could you talk a little bit, here comes one, about your engine itself, the exact VP as well. And I'm not sure what VP means, I'm sorry. Value proposition, thank you. Can you talk about the value proposition of the engine and where you are in the development of that?
Yeah, so the biggest value proposition is the non-combustion part of engine, which will give enough thrust to run the jet engines, subsonic, long haul. But at the same time, the biggest value prop, in my opinion, is it can also go supersonic speeds. So that we have started with the supersonic engine, which will be non-combustion, basically using hydrogen fuel cell. And the non-combustion also means less heat or minimal heat will be generated, which is kind of important for defense perspective, where stealth mode is one of the applications. So a few value propositions there. Supersonic commercial flights will be coming 2030 and beyond. Me personally love to travel fast, and I think most of the millennials, most of the people love to travel faster. So that is also coming. And as I said, supersonic will be 6 to 7 times more carbon intensive. So if we have an engine, we think we have cracked the code for that. If we can use our engine into supersonic flights, that will be zero emissions from day one. So we don't have to create a problem by getting supersonic first and then solving the problem. So we are already working on the problem, or to solve that problem, basically going zero emissions with hydrogen fuel cell based engine.
Got it. Anybody?
Just to add, just to clarify, we have done the patent search. We have done the using global IP firms. So there's nothing like this. So we feel confident that this will work. Obviously, we just have to build it now.
So we have a doubter that says supersonic with fuel cell, and then the conversation continues around, is this going to be liquid or gas storage of hydrogen? Have you gotten that far to make a choice?
Yeah, most likely it will be liquid, but yes, the challenge, the bigger challenge, supersonic, the weight will increase and all that. So we have done the feasibility study using third party, which we looked at additional weight of 30 to 40% because of the hydrogen storage tank as well as fuel cell. So even for that, the 19-seater with supersonic speeds is feasible using our engine, which will be zero emissions. So we have done all that. We can discuss offline the details on that.
So one came in, it's talking from Michelle. Good to see you, Michelle. This one is talking about which countries are providing commercial viability of hydrogen cell engines in or on land or in marine vehicles. Did that make sense to you? Or Michelle, can you just pipe up and say it better than I did? maybe not. So take a shot at it.
Yeah, so yeah, I'll take a shot. Commercially, as far as I know, it's not approved. As I mentioned in the slides, 2025, 26 is the earliest, I think, zero Aviation in UK and universal hydrogen in California. They are looking at it. So they are working with the regulators as well as getting everything certified. But hydrogen fuel cell on land, I mean, that's already used in the automobile industry. But yes, flying the whole system, that is the perception-wise safety challenges are there. A lot of companies are working on it, and then the leakage problems and everything. So,
okay. So Ravi, if you wanted to voice your question, go for it. I saw a thumb. I didn't know if that was a hand or, but Leonard, thanks for the question. It says most of the present pipelines handle below 2,200 bar hydrogen pressure, making technically and economically very challenging to switch to H2 instead of just supplying SAF, right? Midstream. Are there ideas on how much and would be the cost to build the liquid H2 midstream across the continent, that kind of thing? How are you going to supply it?
yeah, so I can be honest saying I don't have the answer for how much it will cost, but we are doing the studies, what kind of hydrogen pressure-wise, 350 bars or 700 bars and all that. So we're doing studies with the partners in Norway and also some partners in Europe and India. So hopefully we have some of those results by end of the year. We are also applying for grants within Europe and Norway to understand these concerns and do the studies to get the answer. We have done, as I said, we have done the feasibility study for the engine itself, that we are confident the weight itself and everything will be okay to fly subsonic speeds as well as supersonic speeds with the way we have designed the engine.
Got it. People like that question. They're curious about the infrastructure and the ability to have the supply where you need it. I don't see any other questions on the board right now. Any other ideas around partnering or other technology questions that you guys have for SiriNoR? Now's a good time. Let's see here. I see something here. What have you built so far? Good question. What actually has been done? What can you show for all of this effort?
Yeah, no, so where we stand right now is we have the design on paper for both subsonic, supersonic. We have done the feasibility studies for both. We have filed for patents. We have the optimal design ready to be executed, meaning the first prototype will be built this year. So we are starting in June. We are raising money for that. We have raised some, so I'm definitely looking for more investors to get to that level. The first prototype that will be built will be to show the engine works and gives enough thrust without combustion. That's the idea, to prove the technology works. Then we'll build, that will be the scaled down version. Then in the roadmap, it will take about 3 years to build the full scale engine that will be ground based, tested with the hydrogen fuel cell system and all, where we're probably looking at $20-25 million of investment. So definitely whoever is ready to invest and taking those risks, welcome to have this discussion here or offline. And
right.
long term, we will be testing it on the jet. We are discussing with some of the aircraft manufacturers as well as airliners for partnership, and some of them look promising right now. So we can discuss all that offline.
Right. And so you have some questions about who you're working with fuel cells, who's going to be the winner in the competition for the field that you're in. And one of the things you shared a little bit on the roadmap, but I mean, is there an area specifically on that roadmap where you're like, we really need to make some headway in this area, or we're looking for partners specifically that you could mention?
Yeah, so the key elements are the fuel cell and the storage, which we're all discussing here, which are the challenges. So sorry, any company obviously a lot of companies are working behind the scene, and most of them are not publishing things. So if you think you are there and would like to partner with us, let's talk. The fuel, in terms of jet manufacturers, we do have a couple of really good discussions ongoing, and if they materialize, things will move faster in terms of other partnerships also. So everything is looking promising this year. So.
Well, a couple of things here. One, Sandeep is saying, hey, I haven't seen Boeing actually working on the hydrogen. Is there any reason for that? And then while you're responding to that, I think Steve came up with the question. No, it was Brian. He's thinking operating costs. What's the cost of operating the fuel cell compared to jet engines? And, how does that pan out?
Yeah, so let me answer that question first. So we did the detailed operating cost per kilometer analysis for 19-seater using the jet fuel versus using our engine. And we also did that for 150-seater. So for 19-seater, I think it's about $0.9 to $1.6 per kilometer for using our engine versus the jet fuel, which is about $2. So definitely cheaper than jet fuel, even for 19-seater. When you go to 150-seater, it's the gap is even significant. I think for 150-seater with jet fuel, the numbers were around $3 or $4 per kilometer, and for us, it's about same, the $1.90, and that's based on the hydrogen cost projections, which are $2 per kg or less. Hopefully that makes sense. If I need to clarify, let me know.
Yeah, and Brian, you can follow up with that if you need to. And then we had this conversation about flowing.
Yeah, Boeing and others, the big players, why they're not doing it. I'm
Right.
sure they are working on things on their own and also doing some partnerships. But at the same time, I can answer this in a way. When I was a VC, venture capitalist, working or investing in startups, every time that question came up, why the big players are not doing it? And the same answer is there. Most of those big players are worried about their legacy business. They have a lot of baggage. They want to make money with existing things, and they let the startups, passionate founders, do the additional work, which will be either groundbreaking or things that big companies don't have focus on. But once the startups prove the technology, then obviously they will either buy them out or partner with them, and then that's how traditionally it has worked in mostly all industries. So aviation is not an exception, I think.
That's kind of a follow-up to the costs of operation. Is fuel cell actually going to be more expensive than the standard, or is it going to be less expensive? And can you just talk about the costs around that?
So the detailed operation cost analysis that we did for with our engine, which also includes, since it's an electric engine, the life of the engine cost is lower because there are less moving parts and all. And obviously the fuel cell cost itself and the hydrogen cost, all of that was included in that. So we can get into all those details, but it's similar to comparing your Tesla car versus IC engine.
So classic here. Hey, are you actually including all the costs like transportation and liquefaction? Is that all built in? That kind of thing?
Not the full value chain. So that part, as I said, it's not.
Right.
I don't have the full handle on, but just when it comes to the engine and how for one particular jet, we have done that. So
right. Okay. Rick Butel, I'm glad you could join us, and I know you're kind of coming down on this conversation. We talked a little bit about, are you at Bloom, are you in conversations with folks that are looking at this kind of system on board? I don't know if you can share what you're seeing from your perspective.
Sure. So I guess depending on where you are, good morning, good afternoon, good evening. And I think that, with Bloom's place in the value chain, particularly around hydrogen, we are talking to, I'll go more than several, I'll say many different project developers who were looking to use our solid oxide technology, not so much as a fuel cell in this application fed by hydrogen, but more as an electrolyzer to make the hydrogen, which ultimately could get consumed in an onboard fuel cell, right, to power aviation. And while I wouldn't say specifically there are people that are focused on, this precise end market, I think what is fair to say is that many of the sorts of projects that are under development and are all waiting for specific Treasury guidance and or waiting for clarity around hub funding, a lot of those are focused on mobility. And what I would say is several of the developers we're talking to have cited not just the mobility cases that we all know well, heavy trucks and buses, but people are talking about aviation now, which I think is very exciting and really builds into the topic that we're talking about here today.
Any feedback, Abhijeet, on that?
Yeah, no, I mean that's excited to hear you guys look at the same way and then working on a lot more projects. So yeah, aviation personally, I think that after pandemic, a lot of people were thinking aviation travel will come down, and also in Europe, the flight shaming campaign is going on. But I don't think the answer is to stop flying. The answer is to find a solution to have a guilt-free travel, which is the electrified traveling. So.
That's right. Any last questions from the group here? We're starting to run up against time. I can see that we've got a case study that's been shared by Kathy. Thanks for that. We have another question. What are the skills required? What are skills required for future ready? Are there skill sets that we don't have yet that we need?
Yeah, that's an interesting question. Yeah, I mean, hiring talent is one of the things I'm looking at, especially when the money comes in. So in terms of for our engine itself, we are, I mean, there is talent already across the world, but to building new talent around the hydrogen fuel cell technology, how to be implemented into aviation for flying and all that, hydrogen storage, that talent is needed. But in terms of if you talk about hydrogen production side and all that, that I think the renewable energy companies have done a fantastic job in terms, and the electrolyzer companies, and also the talent is there. But how do we bring everything together for the top, for especially for SiriNoR jet engine and the electrified jet? That's where we are. We do need to work on a little bit more, and we have to also train some more folks, at least in my opinion. But again, training is a lot easier than the attitude, I guess. If we all have the right attitude and have the right vision, and we all work towards the net zero goals, that's easy to follow. I mean, look at me, I come from petroleum engineering, oil and gas, and now I'm looking into aviation and decarbonizing.
Right on. So talking about money, can you give us a profile for the type of investor that you guys believe you're looking for?
Yeah, I think we do need the patient investors, and also who looking at the impact side of it. Again, we will be a commercial company. Our goal is to end of the day make money, not just it's not a charity, right? So the investors should not shy away from this, saying this is something just to show they are doing something on the impact side. We are looking at financial investors as well as strategic investors. Strategic investors in terms of airline manufacturers, aircraft manufacturers or airliners, engine players and all that. And at the same time, strategics in terms of hydrogen production side, hydrogen storage side, fuel cell. So all of that comes into strategic play. But end of the day, the patient is the key. Patience is the key.
Yeah, so a couple things. Michelle is saying, hey, wouldn't the Norwegian government be a large investor here? They've got tons of money, right? And then the second question that came through is more on the permitting side. And, where do you see the tough spots there?
Yeah, so Norway government as well as European government, a lot of money is there and they are willing to help. And as I said, we are applying for grants. They look at, they don't just give away money, right? So there has to be application written and proper partner should be there. And they're also, one of the condition is whatever they give, we have to match with the private money. So we have to keep looking for private money. So there is, they are willing to give us $2 to $3 million, but also we have to raise from outside. So that's one of the things we're doing.
Okay, super. And then I think that, we're going to go ahead, and do you have any last comments that you want to put out there before we close it down, Abhijeet?
I think just want to thank you for the whole group for making time this afternoon, evening, as I said, and the afternoon. We are definitely excited about this. We are here to go all in and to make this, it's a dream come true in a way, and also to meet the net zero goals. So thanks so much.
Folks, how was the expert talk and discussion today? You can see the survey. Please take a few minutes now and complete it. It makes us get better and make the show even better every time. The post show notes will hit your mailbox very soon with the information that you need. And next up from the experts, the new FTE Hewlett-Packard Enterprise Solving Problems with AI channel starts up. It launches on May 16th with guest expert Dale Brown, Global Head of AI and Machine Learning Software. Leads the discussion is, if AI is the future, why do so many projects fail? On May 19th, FTE welcomes special guest Lorenzo Simonelli, CEO of Baker Hughes, limited seating and sponsorship available. With over 2,000 members, 20,000 followers across more than 25 industries, the FTE network is growing quickly thanks to you. Please check out our library of expert content available to members on YouTube, Apple, Spotify. Register for more shows just like this one on our website at fte.network. Thanks once again, Abhijeet, and to all of you from the experts. And we'll see you next time. Thanks.